So let's say we are going to discuss today about the topics on deep learning. Especially, we'll discuss about the how do we go with the artificial neural network. Okay, so you might be heard of the things terms like neural networks, artificial neural networks. Okay, neurons, convolutional neural networks. Okay, so we are going to deal with such kind of stuff today. So let's see how we can proceed with those neural networks today. Okay, so let me open a. So let's discuss about the neural networks. So what is a neural network? What are neural network? Okay, so here in neural networks we try to teach the or try to train the computer, okay, to do the uh, things which comes natural to human. Okay, so here it's a technique where we teach the computers to do the things which comes natural to the human. Like, so when I speak with you, like how you respond based upon what I'm speaking. Okay, so if a computer can respond in a such way, okay, so such a way we can build the such kind of models using this neural networks. Okay, so neural networks basically uses the one second, one second, I'll present it. So neural networks actually tries to mimic the behavior of human brain. So they tries to mimic the behavior of human brain. So just like how our brain thinks and does the task, okay, similar way it tries to um, do the things just like our human brain. Okay, neural network. Okay, so here, so as we have a fundamental unit called neuron inside our brain. So neuron is a fundamental unit inside our brain. Okay, so similar approach is used to build neurons in computer system the system to do the things, to do the task. Okay, so a neural network tries to mimic the behavior of the human brain. Okay, so here as we use fundamental unit called neuron inside our brain, okay, similar approach is used here to build the neurons in the computer system to do the a particular task. Okay, so example of neural networks. Okay, so examples of neural network, example of the application, okay, using neural network. You might be heard of the things like your Google Assistant. Okay, so wherein it responds to your voice. Okay, based upon that it will do some sorts of searching. Okay, so you may ask it to play music. Say like you may have a devices like smart speakers. Okay, so which can like if you like to play a music, it will play the music. If you want to control the volume, everything you can control via your voice based only. Okay, it responds to your queries also. Okay, it doesn't require any human interface to do that task. It just requires an internet connection and a power supply. Okay, so but at the back end, what kind of algorithms they use is, so they use the such kind of neural networks. Okay, so when we use the a more complicated neural networks, they are called as deep learning. They are called as we call that kind of techniques called as deep learning. When we build the systems using a more complicated neural networks, we call such kind of systems as a deep learning systems. Herein we have variations in the neural networks. So one is artificial neural network, next convolutional neural network, then you have recurrent neural networks, so then there is a other kinds of deep learning techniques. Okay, so these are all your deep learning techniques. Okay, so deep learning techniques, so it is actually what, it's a branch of machine learning which tries to achieve human like performance, or in some time, or in some cases human cannot achieve such level of performance. So by using available data, so normally deep learning models require huge data and high computing systems. Okay, so here the variations are artificial neural network. So simply the neural networks also called as artificial neural network. Then we have a convolutional neural network, recurrent neural networks. So you have autoencoders. So then there is a one more variation called as Boltzmann machines, restricted Boltzmann machine. Okay, so like this we have variations here. So let's see first the artificial neural network. Artificial neural network or simply a neural network, so both are same. Okay, so it is a information processing system, so which is inspired by the way our the biological nervous system of brain processes the information. So it is inspired by the so it is an information processing system which is inspired by the biological nervous system of brain process the system. Okay, so it is inspired by the biological nervous system, okay, such as brain process the information. Brain process the information like our human brain, or you can take consider any other brains. So especially it is basically about our human brain. Okay, so it is basically composed of what, as I mentioned here, it is basically composed of so highly interconnected information processing systems called as neurons. Okay, so it is composed of large number of highly interconnected processing elements. They are called as neurons. So working together to solve a specific task. Okay, so it basically composed of n neurons which actually work together to achieve the required task. Okay, I'll show you something about the image of the our human brain. So how does the neuron looks like? So let me show you the picture of that particular. Whether I have it or not, let me see it. Neuron, it is not there. Okay, it is there here. Okay, so Shabana, can you see this?
Yes, sir.
Okay, tell me the what are the parts we have. Tell me this.
Then actually
Den-
dendrites,
Dendrite,
axon terminal,
axon terminal, cell body,
axon cell body,
inputs.
myelin sheet,
Okay, so myelin sheeted axon, so myelin sheet.
and
Okay,
output.
so you have outputs. Okay, okay. So let me uh, tell me. I'll tell you. This is how actually our human brain has the part. This is one portion we have
Neuron.
taken it. Okay, so these are called as dendrites. What actually dendrites does is they actually receive the incoming input, like whatever we speak, like if you want to hear it, like how so whatever the input goes to our brain, so it actually where it has to be processed, it will be processed by the neuron. Okay, the information is actually processed by our neuron, and then it will get forwarded to the next neuron, or it may be coming as a output. Okay, so but so before it goes to the neuron, it is actually covered by the cell body. Okay, so this is called as the cell body. So this is the neuron which is covered by the cell body. Okay, so here there will be something like some biochemical like it is actually called as a nucleus. Okay, it has it will do some biochemical transformation required for the life of this neuron. Okay, that means there will be something like a liquid will be present here. Okay, so which will be, that is actually inside our human brain. Okay, so these dendrites receives the information, and they'll give pass it to the cell body, from there to the neuron. So neuron actually process this information, and from this tunnel like structure, okay, this is called as a axon. Okay, so this is called as your axon, and these outside layers are called as myelin sheet. Okay, so but this is called as tunnel. From this actually the information will go to the, so this place here. Okay, so which carries the information and transmit to the next layers. Okay, so here you may have a deeper structures, that means so you may have a further neurons and all. Okay, so that highly complicated structure, okay, there will be like hidden patterns will be there. Those hidden patterns will be called as synapses, and these are like external outputs you may get it. Okay, or you may have some other neurons here. So again this information will be received here and it will get further processed. Okay, so that's how actually the information gets processed here. You will receive the inputs from dendrites, so that will go to the cell body. From there the nucleus, so your neurons will process the information and it will go via the axon terminals, axon to the so next body here. So here information will be given as a output, or if you have a complex structure like synapse. Okay, so again further information will be processed by them and then you will get a final output. Okay, so this is how it will happen here in the case of our human brain. Okay, so let me write down those terms here. So what is the first term is your neuron. So what is neuron? It's a or it's called as biological neuron also. It is also called as biological neuron or simply neuron. So it is a fundamental unit of brain and nervous system. This cell is responsible for receiving inputs from external world via dendrites. Okay, second thing is cell body, also called as soma. So the body of the neuron cell, so which contains the nucleus and it is so which transforms some kind of biochemical transformation needed. Okay, so third one you have dendrites. So what they do is, okay, just their uh, task is, okay, these are like hair like structures, hair like tubular structures which receives the data or information from external world. They receives and pass on the information to cell body. Okay, axon, so it is a tubular like structure acts as a transmission line. So next fifth one is synapse. So so here some of the complex, okay, so this is actually so this is actually responsible for the doing the some of the complicated task. Okay, and these performs the some complicated tasks and gives us the final outputs. Complicated complex tasks will be performed and gives out final output. Okay, so this is actually our human brain. Okay, so the same thing, so let us build the same structure like this, so on our own, to build a neural network. Okay, so let me take this paint. Okay, so let me build some of the inputs. Okay, let me consider these are my input samples, right? So let's say you can consider, so these lines as, so this is one neuron which is accepting these inputs. Okay, so and this is going via the dendrites. Okay, so this is actually your neuron, say like neuron, and here is your inputs, and so now followed with the dendrites are there. So as I said, so this cell body, okay, which is collects, which will be having a some kind of nucleus, that means some information, some energy will be there. Okay, so it's responsible for what, the life of the neuron, right? The cell body is responsible for the life of the, so neuron. Okay, one minute, it is responsible for, so life of neuron. Okay, so the neuron to be active, so there should be some energy at the beginning. Okay, that we call it as a weights, that we call it as a, so weights. Okay, so that will provide it here. Okay, so let me write some weights. Okay, so now this is the incoming input, so represented as x, n. So if I'm considering this as x naught, and this will be your x1, x2 up to xn. Okay, so that's how we do it. Okay, so now, so you have this one, and now this will be collected here, right? So this information will be collected here. So this is where the collection happens, all the information. So this is some, like it will collect the information and process it, right? Neuron will be processing that information. So I call this as a summation. So what actually happens here mathematically, so summation of your I equal to, okay, if you're starting with 0, so till n, so what I have to do is, your inputs is x I into the initial weights, that is initial energy inside your neuron, so that will get multiplied, that is w I. Okay, so this is the mathematical term. Okay, so we are representing here. So this information will be next processed here. Okay, so that is via axon it will get transmitted. Okay, this is your axon. So here you will get your final output. So this is your output. Okay, so but as we told here, okay, so what actually cell body does, Shabana?
Yes, sir.
So what actually it is doing? It is doing what? Some kind of
Uh,
biochemical transformation,
it
right?
is doing some biochemical
Transformation.
transformation.
Okay,
Yes.
so but actually what
To
we
keep
did
the
is
neuron
neuron,
alive.
neuron is just collected the information. Still we are not did any biochemical transformation is not yet done. Okay, so we need to apply that biochemical transformation. Okay, so that means the cell body will decide whether to process the information output out or not. right? So if it is not doing any biochemical transformation, it means what? You are not getting any output from that neuron. Yes, the similar way here, so there will be a one function which will be uh, responsible for deciding whether the neuron should be active or not. That means whether we should consider the output of the neuron or not. Okay, so that transformation will be done by something called as activation activation function. So what is the role of activation function? So it is responsible for it decides whether to get whether so neuron should be active or not. Okay, that's what it does. Okay, so it applies so required transformations on the neuron processed information. So after neuron process the information, okay, your activation function will decide. So it applies some kind of transformation. Based upon that, it will decide whether to the neuron should be active or not. Okay. So then you may have a final output here. So your output is also called as a neuron. Okay, so this neuron, again, this will also have a activation function. So based upon that one, we will get the final output. So in between, if you have a further neurons, okay, so in between, if you have a further neurons to process it, so these will be required when we have a complex task to process it. Okay, at that time these are called as synapses. What are synapses? So these are like hidden structures, so which will be useful for doing the complex task. So this is called as, one second, so these in between structures are called as hidden structures. Okay, so we call them as hidden structures or neurons. Hidden neurons also they are called as. Okay, so they are hidden layers also, you can use it. Okay, so this is your final output. Okay, so here also you'll use the activation function, which will decide whether what sort of output to get it. Okay, so we try to build such kind of model mathematically. Okay, so neural network we do the similar approach as we do it in the, as it happens in the our biological neurons inside our brain. Similar approach is used here in mathematically in the neural networks. Okay, so this is clear. Okay, so this is how we build the neural networks. Okay, so here let's see how what actually happens here, how it actually processes the information and how it tries to get the final output. Okay, so let's say there are few things, few steps are available here in your neural networks. Three steps, two actually main step, two main steps and two important functions. The first step is forward propagation and second step is backward propagation. Okay, so here two important functions. One, during the forward propagation we use something called as activation function. Here in the backward propagation, so important formula is gradient descent algorithm, or we call simply, I'll call it as a optimization algorithms. Okay, so let's start with them. two main steps and two important functions. What is forward propagation? Okay, so in forward propagation, so we try, so in forward propagation, so data input will be collected and processed by neuron. So in forward propagation, okay, so again first step what happens is data input will be collected and processed by the neuron. Okay, so let's see what will happen here in the forward propagation. Okay, so let me take a new file. Okay. So I'm going to consider only one input sample and one neuron and one output. Okay, so let me collect. So let me name this as a let me name this as a x1. Okay, so here you will have w1, that is your weight. So this is your output of the neuron. Okay, so what is the output here? Shabana, so what is the, what actually does it do here? It does the,
It is sending something.
only,
Answer.
so only multiplication will happen, right? Because summation is not required, because we have only two, only one input sample is there, right? So here,
W1 into
yeah, w1 into x1. So if I'm naming this as a z, okay, so now your z is equal to what? X1 into uh, so w1. Okay, so this is what happens. Okay, so now, so output of this one, say example I'm taking this value as 0.1 and this value as 0.1. This is consider, let me consider this as 0.15 input. Okay, so what is the output here? 0.15 into 0.1, so this is equal to what? 0.015.
015.
So this is your output. Okay, so now this will be what? Subjected to which function now? You have to, it has to be passed through activation function. So that means who will be doing it? Cell body. Okay, which will decide whether to pass on this output or not. Okay, so mathematically what is activation function? What sorts of activation functions are there? Okay, so here we have uh, many types of activation functions. Okay, so second one, activation function will decide processed information is useful or not. Okay, so what are the different types of activation functions? Okay, so there is a activation function called as sigmoid activation function. Okay, so this is sigmoid activation functions. Okay, so here output y is equal to given by 1 divided by 1 plus e to the power of minus z. Okay, so this is e to the power of minus z. Okay, so basically this is the a sigmoid activation function. If I look at this sigmoid activation function, okay, so let's take a box here and draw a line here and I'm marking this as 0. Okay, So this is your Z. So maybe here actually I'm starting with the 0. If you consider, it may be 0.15, something like that, in between value. Okay. So normally what happens in the activation function is, so if you performing the sigmoid activation function, if I'm doing sigmoid activation function, sigmoid activation, okay, its graph looks somewhat like this. Okay, so its output always ranges between 0 to 1. Okay, and it will be having a structure like this. uh, it somewhat looks like this. Okay, it will be somewhat like this. So here it is. 1 second. So this is straight line over here. Okay, so if I'm taking this value as starting 0, okay, z value. Okay, so here if I'm going with the positive values, and here this side I'm going with the negative values. So as you have more negative values, the output comes, this output, so comes close to the 0. As you have a maximum value, it goes close to this value here. So this is will be your maximum value of 1, this will be 0. Okay, so here output will be always decided between 0 to 1. The output will be between 0 to 1. Between 0 to 1 always. So that means if you're having a higher values, okay, so they will become 1. So lower values which are less than 0 will become so close to the 0 value. So if you're using a sigmoid activation function, say example, I'm going to use another function. Okay, so let me show you another simple function. So it's binary step function. Another function will be binary step function. Let me take it as, in binary step function, binary step function, sorry, 1 second, binary step function. So here threshold will be based upon the activation function. If the input value is above or below some threshold, so neuron will be activated, otherwise it will be simply kept as it is. Okay, say example, so if you're having a so threshold as t, this is considered as threshold. Okay, so if y is greater than t, okay, so neuron will be activated. If y is less than t, neuron deactivated. Either you will have a result or your output will be 0. Okay, so you will not have any other outputs. Okay, so either you will be uh, get output as 1 activated, so then y will be equal to 1. So deactivate means, so y will be equal to made 0. Okay, what is y here? So, sorry, not, I'm not taking y, so x, you can say z. Okay, here we are using right z. Okay, so your final output will be equal to 1 or it will be equal to 0, final output. If z value is greater than the threshold whatever you set, so output will become 1, otherwise output will be 0. So this is less than t. So that means you will be switching either between 0 and 1 outputs. Okay, so normally this kind of function will not be used much, activation function. So but activation function are generic, so that's why I'm telling what are the different activation functions available. Okay, so then third most important one, so Relu activation function. and we are going to use this most widely, Relu activation function. So here, so your output will be decided so based upon input. So normally your output is equal to 0 if your x value is less than 0. That means your g value, okay, if it is less than 0, so your output will be 0, and your output will be equal to z if z is greater than 0. Okay, so whether if it is greater than or equal to 0, so then output will be equal to z only. So that means if I am using a activation function here, so output is greater than 0, so that means your output is also going to be the same if I am using a Relu activation function. So if I am using Sigmoid activation function, so what it does is, okay, so it calculates using this formula, that is, so your output will be equal to what, based upon this formula, 1 divided by exponential of minus z, 1 divided by 1 plus exponential power of minus z. So that will be computed, and then you will get a final your output y. Okay. So got it. So these are the three different activation functions. So there are many are there, so but we are not going to discuss all of them. So I discussed the most important one. One is sigmoid, and one more is the Relu activation function. These two are very much important, and we will be using them frequently. So any questions regarding this? A, and this is your B. Shabana?
No, sir.
Okay. Rohit? Any questions?
No, sir.
Okay.
No, sir.
So now what you will get, finally you have the output, right? Okay. So you have done in the forward propagation. First step is what, Rohit? What is the first step? So you will, the data will be collected from the input and it will be passed on to the neuron, and neuron will process that information. Okay. So then activation function will decide whether to pass on that information or not. Sometimes it will pass on the information as is, so based upon the activation function. So or else there will be some kind of biochemical transformation like activation function. If you are using sigmoid, so it does some kind of transformation will be done using sigmoid. Okay. So then third step, so we will get the final output. So we will be getting the final output. Okay. So now fourth step. So now output will be compared. Not, this is not the fourth step. So we'll get the final output. Okay. So we'll get the final output. So this is called as predicted output. Predicted output. Okay. So we got this one as per this diagram. So we processed and we did this activation function has been passed. So then you get the output to be passed here. So you'll get a final output. Okay. So next what? Whether the output you got is correct or not, how you will get to know it? So whether the output we received is correct or not, how do we get to know it? Anita? Anita? Can you hear? Okay. Magita?
Yes, sir.
So tell me, how do we get to know whether the output we received is correct or not? Say like you have told the model to predict the character A. Okay. So you are told the
Okay.
model to predict the character A. Okay. You have passed it and it processed it. Maybe like it recorded its features and it processed it here and you got some final output. Okay. So whether,
Okay.
so this is correct or not? So whether we output we received is correct or not, how do we going to decide it? Okay. So normally what we'll have, so we'll have a ground truth, remember? So we will be having a ground truth. Okay.
Ground.
So here actually this neural networks uses the ground truth because they are supervised learning concept currently. Okay. So in the supervised cases means we will be having a what is the output required. We will already know about it, right? So that means
Yes.
so predicted output. Okay. So next step is your backward propagation. Okay. So you are going to do the backward propagation. So now in backward propagation what happens is, okay, so predicted output will be compared with the ground truth. Okay. So then and error will be calculated. So we compare the predicted output with the ground truth and the error will be calculated. Okay. So let's say, okay. So now Shabana,
Yes, sir.
so you have kid, right?
Yeah.
How many years old?
2.5.
Two and a half. Okay. So what are you teaching him? So what you're teaching, like are you teaching anything like alphabetical characters? Are you teaching them now?
Yeah, sir.
So you're
Yeah.
teaching. Okay. So you might have experienced this, like just comparing like how actually so our human, okay, we learn, okay, the same process actually applicable here also. Okay. So maybe when you so you so male or female baby?
Male. Male,
Male.
sir.
Okay. So so you told him to write like he is able to write A, or can he recognize A B C D?
No, not at still.
Not it. Okay. So you not yet tried. Okay. So when you try it, you will get to know it. But you already know some of the problems also. So this is actually how does the A looks like. So
Yeah.
so
What?
one second, I'll just take it. A. I'm making this as a bigger one. Okay. So you if you tell him to write, okay, A. See, he may write again on this one. Maybe like he will be writing something like this at the beginning. Okay. So will you give only one chance, or you will give multiple chances to him?
Multiple chance.
Multiple chance. Then only he can improve, right?
Yes.
Okay. So depending on the kids, like what do you call IQ level? Some kids may take less time. Some kids may take more time to get the same output, right? So, but here, same thing here in the case of neural networks also. Okay. So in the backward propagation, what we do is, so this is actually you will do the comparison, right? You are actually behaving there as a optimization algorithm. Like you are actually as a teacher, what you do is you know how does A looks like and how your kid has written, and you do that
Yeah.
comparison and you tell that this is a correction you need to make it. Yes.
Yes. Yes.
Okay, the same thing happens here also in the backward propagation. So predict, so we predict whatever the predicted output will be there, so that will be compared with the ground truth and you will get a error will be calculated. Okay. So this error will be passed back to the neurons. Okay. So error will be passed back to the neurons. Okay. ಸೊ ನೆಕ್ಸ್ಟ್ ಈಗ ನೀವು ಎರರ್ ಕರೆಕ್ಷನ್ ಏನಿದೆ ಹೇಳಿದಿರ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡಬೇಕು? ಕರೆಕ್ಷನ್ ಹೇಳಿದ್ಮೇಲೆ so you need to tell how much correction he will be doing it. He will decide it, right? Some correction, or else what you will do is you will take his hand and you will try to write it along with him, right? So you will be writing along with him. That's some sort of correction. Okay, suddenly all of a sudden you will not let him to write, right? So at the beginning what you will do is you will hold his hand and then you will start practicing it. So that's how you will do it. Or directly you will go and give him a pen
No.
and you will tell him to write it. No, right? So same thing here. So
No.
we will be using something called as gradient descent algorithm. So its role is to minimize the error. Okay. So minimization error minimization needs more time, less may take less or more time based on data and learning rate. So what is learning rate here? Learning rate, here we are going to decide the learning rate. Okay, so normally if you're choosing the learning rate as 0.001, that means you are selecting it as 0.1%. Okay, so that means your initial weights, so these are actually weights, right? These are not we have given, these are like initially the energy present inside your neurons. Okay, so that initial weights will be close to zero. Those values will not be zero, they will be very close to zero, they are not a higher values. Okay, that means your kid have some like he has some energy, like he knows like how the your characters looks like based upon some of the previous maybe like, so it's a very complicated thing. Okay, if you have to talk about it. Okay, but still he has some idea about it. Okay, so when try to write it he gets some errors. Okay, so like this your neuron got some of the energy, so but that energy is not useful here because the error you got is more, but we need to change the weight values, we need to adjust the weights. Okay, so how to adjust that weight? All of a sudden from this value 0.12 can I change it to 0.2 to get a final output, or should I change it as 0.11 or 0.12, something like suddenly from 0.1 to 0.12 should I change it, or should I make it as 0.11, or should I make it directly from 0.1 to 0.2? Changing this initial weights changes your output. Okay, so but certain times what happens is you may get a correct output or may not be there. Okay, that's why you need to control the learning rate. Learning rate always should be less. Okay, so that you can have a gradual decrease in the error. Okay, so you may have a error level here at this moment, and next level it may reduce to this, next it will be reduces, and you may have a final zero error here. There is a chance like it may increase also. Okay, when there is a chance it will increase, if your learning rate instead of going from one step to the next step, suddenly if you're going from this step to this step, okay, you may have a chance of skipping this minimum, reaching the minimum value, suddenly going to the next level. So to avoid that, so we use the learning rate, a less learning rate will be used. Okay, so gradient descent algorithm, it's an optimization algorithm. What it does is it tries to minimize the error. So by adjusting the weights, okay, so by adjusting the weights of the model. Okay, so model means the neural network model whatever we created. Okay, so by adjusting that, so we'll try to connect it. Okay, so so gradient descent algorithm, its role is to minimize the error, so by adjusting the weights of the model. Okay, so error minimization may take less or more time, so based on the data and the learning rate we set it. Okay, normally we set the learning rate at this value. Okay, so now consider you adjust the weight means, so you told your kid to write it once again. Okay, so he has written now once again. Okay, so will you be happy with this result, Shabana?
No.
So if you are
You
not
have to
happy,
give
that
chance
means
to improve.
error is more. Still error is there, but it is less compared to the previous error. Okay, so then you will give more chance to him. Okay, how many how many chance you will give it to him? Is there anything like you don't have any idea, right? Only when you start writing,
No.
so based upon that you may think of something like that, right? So whether to give him 10 times chance or 20. Okay, so if I'm taking generally, okay, it purely depends on what here in mathematically, for our case it purely depends on the data. Okay, so in your case
Okay.
it depends on your kid. Okay, as it depends on your kid, okay, how many times he needs. Okay, so here also depending on our data we may give the more time to do it. Okay, so more time giving means it is called as number of epochs. The term we are going to use is called as number of epochs. Number of epochs. What is number of epochs? Okay, so one time forward propagation and one time backward propagation of the whole data. Okay, you call that as a epoch. One epoch is equal to what? One epoch is equal to one time forward propagation and backward propagation of the whole data. Say example, uh, if I'm trying to do that example of prediction, say like I'll give you one simple example here. Can you just predict? Oh, so this is the input. Okay, so this is the output. I'm going to get it. Okay, 4, 5, 6, 7, 8, 9. So this is our output. So this is my input. Now, so here, Shabana, one thing you remember here. So we have first thing is one iteration. One iteration. One iteration means what? One time forward propagate
Propagate.
and one time backward propagate, get the data, one sample. That means I'll forward propagate this number 1. This is the first sample, right? So how many features
Yes.
are there in the input? Only one feature is there. Total how many samples are there? 6 samples are there. Okay, so I'll propagate this one first time and it will be processed by your neuron. Okay, so it will be processed by your neuron. Okay, and here you will get some output and that will be compared with your ground truth value of 4, and then you will get the some error, so that you will backward propagate that error and you will adjust the weights. This happens in one iteration. Okay, the same thing happens to the second sample, third sample, fourth sample, fifth sample, sixth sample. So once you complete forward propagation of all the samples and backward propagation of all the samples, you will call that as a one epoch. Okay, so one epoch is completion of all iteration. Okay, so how many times this data will get iterated? 6 times it will get iterated. Okay, 6 times total iteration. Number of iterations it requires is 6 iteration to complete this one epoch. Okay, to complete one epoch it requires 6 iteration. So in above example, to complete one epoch it takes 6 iteration. Example, so if you are teaching your kid learn A, B, C, D, 4 characters. Okay, so for A you will one time forward propagate and backward propagate. For B you will forward propagate backward. Andre A ಯಾವ ಥರ ಬರೀತಾರೆ, B ಯಾವ ಥರ ಬರೀತಾರೆ, C how he is writing C, how he is writing D. You will check for everything. Okay, and you will tell him to do what are the corrections for each of them. So that is called as one epoch total. Okay, each correction you are doing is called as one iteration. Okay, that's how we can like compare this with how so we do the things. Okay, so right, all right, so that's how we did it. Okay, so this is called as epochs iterations. Okay. So got to know, tell me like now can you repeat like what actually happens in neural networks? How does the neural network process the information? Okay, Rohit. Rohit. So we shall summarize this thing about neural networks working. Can you hear? Rohit? No. Shabana, can you hear?
Yes, sir.
Okay, Shabana. So just quickly we'll summarize this thing. So what actually we do it in the neural network. Okay. So tell me what we do it. So we do the.
Actually,
Huh. Tell me.
uh, when we get the inputs,
Mm-hmm.
uh, we see that it is passed on to the next level, and activation of the activation record means if that input is validated, only then it can be passed on to the next level.
Okay.
That
Input
happens.
will be processed by neuron. Okay. Second step, the processed data will be subjected to activation function, right? So
Yes, sir.
subject
Uh,
to
Either it can be
activation function, we will get output if neuron activated. Okay. So then if no hidden layers present, okay, so there will be something like hidden layers will be there in between. That means in between this neuron to the, this is input layer, this is called as your output layer. Okay, so this is your neuron. Okay, so in between you may have some hidden layers. Okay, so if the hidden layers will be useful for doing the complex task. Okay, if no hidden layers present, so then we will get, let's consider if hidden layers are present, they will further process the information and then pass on to output layer. Fifth one, so output layer will give us final output. Sixth step, so output, so before we get final output, backward propagation will be computed. Okay, so backward propagation ಏನೇನಾಗುತ್ತೆ, so seventh step, calculate error. So send back, transfer, um, propagate error back to neurons, adjust the weights, and again ಏನು ಮಾಡಿದ್ರೆ, after adjusting again what, again process the information. Okay, so now repeat these steps to 9. Okay, this is again, okay, till number of iterations, number of epochs gets completed. Okay, so this is what happens in the neural network. Clear? Any questions? Okay, So, Magita,
Yes, sir.
so is that clear?
Yes, sir. Okay, sir. No problem.
Fine.
No
Okay.
doubts.
So so let us start here a lab session, like how we build it. Okay. So for building neural networks, okay, so we will not try to build all these steps. Okay, we'll use the libraries for this one. Or what are the libraries required? Okay, so the libraries used will be TensorFlow and Keras. So TensorFlow is a library for deep learning provided by Google. It is a low level library to build neural network models or deep learning models. Okay, Keras is a high end high level library built on top of TensorFlow for modeling neural networks. Okay, so TensorFlow is a low level library for building the neural networks. So instead of that, we will be using the high level library called as Keras, which internally uses what? TensorFlow. So that means we need both the libraries. If you want to use Keras, TensorFlow is mandatory to use it. Okay. So here one thing is you can install the TensorFlow library. Okay, so by going to the this one command prompt. Okay, anaconda prompt is there. You can open the anaconda prompt. So you need to install these libraries. These libraries will not be part of your anaconda package. They will not come with a default installation. Okay, so we need to install them separately. How to install it? Okay, so either type pip install tensor flow. So this is the one method of installing it. Okay, so to install TensorFlow and Keras, open anaconda prompt in Windows. In Ubuntu, open terminal. So you will be having a terminal in Ubuntu. You can open that one. Okay, so now to install it, type install pip install TensorFlow. So after completing this, okay, you can go for pip install Keras. Alternative is, okay, conda install. So there is a command. Give me a second. Conda install -c -forge. Like that. It is there. 1 second. Commands. Okay, conda install -c conda -forge tensor flow. You can do this one. Okay, so then similarly you can do the same repetition. Instead here you will type Keras. So now in between what you have to do is, before you do this step, conda update, you do it update Anaconda before you do the installation. Okay. See, but this installation will be complicated. Okay, sometimes the installation may not happen. Okay, so you may get some error here. Okay, so instead to avoid all these things, okay, to avoid all these errors coming, so what I'll do is we'll suggest using the Google Collaboratory. We'll suggest using the Google Colab. So if possible, try to install this. Okay, so tomorrow I'll show you how to work with the lab session on the same exam. Okay, so based upon the neural network, how to process further. Okay, so we will be doing it tomorrow onwards, Google Collaboratory. So how to do it in Google Colab and all. So in tomorrow's session, I'll be showing that. Okay. So if you are able to install it, okay, so just open a notebook. Okay, just open a notebook and simply type import Keras. If it is importation is happening correctly, so then you can we will work in the local system, or else we will use in the Google Colab. So just type import Keras to check whether installation is completed or not. Okay, so this may take more time. Okay, so here it is not installed actually in this system. We are getting the error here because it is not installed here. So but if you don't get any error like this, so we will be using it. But in another system I done the installation, here it is not done. So I'll show you both how to do it in local system and as well as in the Google Collaboratory. Okay, it's an online platform for doing all sorts of programming. Okay, and it is freely available, and it comes with most of the libraries loaded inside it. Okay. Fine guys, that's it for the day.